Hello folks, coming to you today from video, and we are going to begin our work on right triangle trigonometry. Great news, we're going back to the Algebra 2 books. So starting on Wednesday when I'm back, you can bring back your pre-calculus books. I'll be checking those off on Wednesday. So now, right triangle trigonometry is the study of the measurement or measurements in a right triangle. And today, specifically, we are going to look at 3 trig ratios. Alright, a trig ratio is a ratio that compares the lengths of two sides of a right triangle. And depending on which two sides you have, will determine which trig or trigonometric function that you can use in your calculation. So if we look down at the triangle, first of all, again we have a 90-degree angle always, and then we will have another angle, and we're going to call that theta. That angle is theta. Okay. Now, as we look at the sides in relationship to theta, we have one that's across or opposite. We have one that's adjacent or next to. And we have the hypotenuse, which is the longest side of a right triangle. Also, for those of you that are paying attention, a hypotenuse is going to the bathroom on an airplane. Pause for laughter. Alright, moving on. Our first trig function is the sine function. Not sin, but the sine function. That function can be used in the calculation whenever you are taking the ratio of the opposite over the hypotenuse. The sine of theta is the opposite length over the hypotenuse. The next trig function is the cosine function, which is the adjacent over the hypotenuse. Cosine function, adjacent over hypotenuse. And the third trig function is tangent. The tangent function is the opposite over the adjacent side. Oh, and by the way, a tangent could also be an English guy who's hung out on the beach too long. Pause for laughter. Alright, now, a lot to remember. I get it. So we're going to give you a little saying to remember these trig ratios by. So up at the top of this new slide, you can see the word or the phrase SOHCAHTOA. SOHCAHTOA. And by looking at the letters, this first one is going to remind us that sine is opposite over hypotenuse. So, the second one is going to remind us that cosine is adjacent over hypotenuse. So, ka. And the last one is going to remind us that tangent is opposite over adjacent. Toa. So all together we have, let's say it all together. Ready? 1, 2, 3. SOHCAHTOA. Very good. Alright, let's move on to a problem and see how this goes together. Alright, so it says find the missing angle. Again, remember that math symbol is theta. It's an angle. And we have to look at the sides we have in relationship to theta. That's the opposite side. And the one over here is the hypotenuse. So opposite over hypotenuse. That is the SO in SOHCAHTOA, the sine of theta equals 3 over 5. I know the sine of theta is 0.6. Now, in order to calculate in this example what theta is, we're going to need the inverse of sine. We're missing the angle now, and in order to figure out the angle, we have to use something called the sine inverse function. Okay, and we're going to take that at 0.6. Now, again, if we're missing an angle, okay, we're going to use the inverse trig functions. Inverse sine, inverse cosine, inverse tangent. So on our calculator, we can type in sine of inverse and put in the 0.6, and that should give us a angle of 36.9 degrees. Okay. Now if you want to pause this, right now would be a good time, and you could practice using that sine inverse key on your calculator. We have to make sure that all of our calculators will have a mode button, or the ability to get our calculator into degree mode. There's another choice called rad, and we're not going to work with that yet. So it's important to make sure that you're in degree mode. Alright, moving on. Next example says find side B. Now what we do in our triangles is the capital letters are angles, and the side across from that angle is the lowercase letter. So B in this case is the hypotenuse. Okay? If I look at angle 52 and look over, the 8 is the opposite angle. Okay, so I'm going to set up an equation. I have opposite and hypotenuse, and if you think back, that's the SO in SOHCAHTOA. So the sine of 52 degrees is going to equal the opposite over B, the hypotenuse. Okay, now I'm going to have to do some algebra here, so I'm use my calculator, so I'm getting that out for us. Now, if I do some algebra, I'm going to multiply the B over to the left side, and to get my result for B, I'm going to take 8 and divide it by the sine of 52. Alright, so I'm going to punch that 8 divided by the, excuse me a second, 8 divided by the sine of 52 is equal to 10.2. 10.2 is side B. Again, you can pause and make sure you're operating your calculator correctly on that problem at this point if you'd like. Okay. Alright, moving on. And these examples are called solve the triangle examples. And what we're going to be trying to do is we're going to draw a picture. I need a right triangle. Okay. It tells us that angle C is the 90-degree angle. Angle A is 40. And that allows me to know that angle B is 50 right away. And solve the triangle means find all the sides and find all the angles. So I already know the measure of angle A is 40. The measure of angle B is 50. And the measure of angle C is 90. So I have that. All that's left to do is find A, B, and C sides. AB is 12, and that corresponds to little c. Now, in order to find the other sides, I'm going to have to use some trigonometry. And if I think of the 40 over here, that's going to help me find A. The sine of 40 is the opposite side A over the hypotenuse 12. And if I want to solve that, I'm just going to multiply the 12 to the other side. Let me grab my calculator again here. And I'm going to multiply those two together. The sine of 40 times 12 equals, A is going to be 7.7. Now B here is the adjacent side. So I can go cosine of 40 equals B over 12, or 12 cosine 40 is B. Once again, I can put that in my calculator. Cosine of 40 times 12, and B is 9.2. And now I have all parts of the triangle, 3 angles, and 3 sides. So I have solved the triangle. Alright, moving on. Actually, I think that's the same problem, folks. So we can get rid of that one. We have one more idea: angle of depression and an angle of elevation. So the angle of depression is going to be any angle going down from the horizontal, and the angle of elevation is the angle going up from horizontal. Okay? So let's take a look, and we're going to call this theta. We'll come back to these two in a minute, but let's try this angle and look. Okay, the side across from the angle is 6, and then I have the hypotenuse here. So that's SOHCAHTOA again. Sine of theta, 6 over 10. Oh, I think we might have started with this example. Let's look back. Close. So that's the 0.6 again. And so we do the inverse, 0.6, and I think early on we saw that that was 36.9. So a repeat problem. Sorry about that, folks, but that's quite okay. And now our last example of the day is a word problem. It says a prince is trying to decide the length of the ladder. So I'm going to call that X, needed to save the princess from a balcony. The height from the balcony to the ground is 74.5 feet. And the angle of elevation, so from horizontal going up right in here, is 60 degrees. How long must the ladder be? So I have a 74.5 as the opposite, and I have the ladder, or X, as the hypotenuse. So again, that's SOHCAHTOA. So the sine of 60 is 74.5 over X. Alright, we're going to multiply by X. And then I'm going to divide by the sine of 60 to see what we get. And let me pull out my calculator again. And we will go 74.5 divided by the sine of 60 comes out to be 86.0 feet. And again, a good time to pause your calculator. I'm sorry, pause the video and see if we can get that with our calculator. Alright, a couple announcements. Your, actually not quiz, but test scores. School view at the end of the night, end of the evening. Alright. Assignment will be the SOHCAHTOA worksheet. Enjoy. Have a great day.